Welcome to another video of BISP Solutions CFA Level 1 Examination video series.
All right, CFA candidates, welcome. We are diving into a high-yield review that's going to lock in one of the most critical concepts for your exam. We're talking about arithmetic versus geometric mean. And trust me, understanding this isn't just theory. It's how you're going to bank some serious points. Let's get right into it. So, this is the big question, right? You see a bunch of returns and you have to decide. Which mean do I use? This is not just some random math problem. It's a classic way the exam tests if you really get investment performance. Our mission today is to make sure you nail this question every single time. Okay, let's kick things off with our first contender. This is the one we all learned way back in school. It's super straightforward, it's simple, and it has a very, very specific job in finance. This is the arithmetic mean. The key question the arithmetic mean answers is this. On average, how much did I earn per period? Now, the magic words there are per period. It treats every single period like a totally separate, standalone event. It's just the simple average you've known forever. And yeah, the formula is exactly as simple as you'd think. You just add up all the returns from each period, R1, R2, and so on, and then you divide by n, the number of periods you've got. Clean, simple, and direct. Okay, let's run the numbers real quick. Imagine your returns were plus 10%, then a great year at plus 20%, followed by a drop of 10%. First, you just add them up. 10 plus 20 minus 10, that gives us 20%. Then, since we have 3 periods, we divide by 3, and boom, you get an average return of 6.67% per year. That's your typical return in any single year. So, when is the CFA Institute actually going to ask you to use this thing? Well, it's mostly for forecasting or when you're calculating an expected return for a single future period. Think of it as a forward-looking short-term tool. It's also a bedrock assumption in big models you know and love, like the Capital Asset Pricing Model, or CAP, AMP. All right, so that's contender number 1. Now let's bring in the second one. This one is more sophisticated. Why? Because it deals with a massive reality in investing: compounding. You know, the idea that your returns start earning their own returns. It's time to talk about the geometric mean. And just look at the difference here. The geometric mean answers a totally different question. What was my real compounded return? This tells you the steady, constant rate your money would have needed to grow at, year after year, to get from your starting point to your ending value. It reflects the true investor experience over the long haul. Now, the formula might look a little scary, but it's actually beautiful. See how we add 1 to each return? That's what turns a percentage into a growth factor. Then we multiply them all together, which is how we capture that compounding effect. We take the nth root to smooth it out into an average periodic growth factor, and then, last step, we subtract that 1 to turn it back into a nice, clean percentage. Let's use the exact same numbers as before: 10%, 20%, and negative 10%. First, we turn them into growth factors: 1.10, 1.20, and 0.90. Multiply them out, you get 1.188. Since it's 3 years, we take the cube root of that, which is about 1.059. Subtract 1, and there it is. Our actual real-world compounded return was 5.9%. Now notice, that is lower than the 6.67% we got with the arithmetic mean. And that difference, that's the whole point. So when is this your go-to tool? Anytime, and I mean anytime a question is about historical performance over multiple periods. If you want to know what a portfolio actually returned, what the investor really experienced factoring in compounding, the geometric mean is always the right answer. It is the backward-looking measure of true, realized performance. Okay, now for the main event. Let's put these two side by side. Because understanding the differences we're about to cover, this is exactly how you're going to nail these questions on exam day. Welcome to the showdown. This table right here, this is your cheat sheet. Let's break it down fast. Meaning: simple average versus compounded return. Use: forward-looking expectation versus backward-looking actual return. Time horizon: short-term versus long-term. And the most important one, the one that makes all the difference: volatility impact. The arithmetic mean completely ignores it, while the geometric mean captures it. And that last point, that is everything. Okay, this brings us to a fundamental rule. This is non-negotiable, you must memorize it. The arithmetic mean will always be greater than or equal to the geometric mean for a series of returns. The only time they are equal is if there is zero volatility, if every single return is exactly the same. The second you introduce any ups and downs, the arithmetic mean will be higher. And here it is, the big exam trap. This is where so many people get tripped up. Because the arithmetic mean ignores volatility, it always overstates the true long-term performance of an investment. Think about it. A 50% loss requires a 100% gain just to break even. The simple average totally misses that painful reality. But the geometric mean, it captures it perfectly. It gives you the true, sober picture of what actually happened to your money.
All right, let's shift gears. We've gone through the theory. Now it is time for the game plan. This is a rapid-fire review to burn the key takeaways into your brain for test day. Ready? Let's go.
First up, a dead simple memory trick. If the question sounds like it's asking for a simple average or a forecast for one period, think A for arithmetic. If it's asking about actual historical growth over many periods, think G for geometric. A for average, G for growth. Lock it in.
Okay, listen closely. This next sentence, you need to burn it into your memory. I'm going to say it twice. Arithmetic mean is appropriate for single-period expectations, while geometric mean is appropriate for multi-period returns. This exact concept is tested over and over and over. Know it cold.
All right, final tips, let's hit them fast. 1. Focus on interpretation, not just the math. The real test is knowing which one to use. 2. One-period expectation, you're using arithmetic. 3. Multi-period growth, it's geometric, every time. 4. Remember, just one negative return will create a huge gap between the two. And finally, don't sleep on this topic. It's an easy, frequently tested, high-scoring area that you just can't afford to miss.
And let's wrap up with this final thought. When you master the difference between these two means, you are doing so much more than just studying for a test. You're learning to tell the difference between a simple forecast and the hard, cold reality of compounded returns. You are learning to think like a real investor. Now go crush that exam. Good luck.